Hi everybody, Derek here, and like many of you, I'm working from home. I decided to take this opportunity to learn something new around machine learning, so I picked up the NVIDIA Jetson Nano, as well as all the accessories in our Deep Learning Institute DLI course kit. This kit has everything you need to get up and running with your NVIDIA Jetson Nano, as well as start off by taking the Deep Learning Institute, the DLI course, which is free online, provided to you by NVIDIA. I took the course. It was actually a really good introduction to machine learning for me. There's a lot of great example code and projects that you can do with very few items. But it left me wondering, what was my next step? What was the next step between what I just had finished and a self-driving lawnmower? And so I picked up a couple of SparkFun components, the quick OLED display and the quick servo hat, just to see what it would look like to incorporate some SparkFun hardware into the already existing DLI course examples, and then how to do that. So with that, let's jump in and take a look. Before we jump into programming our NVIDIA Jetson Nano, let's assemble our hardware. First off, the SparkFun servo hat. And of course, if you have a servo hat, you need a servo. Our quick OLED display. And a SparkFun quick connector cable. Now the heart of this is going to be all the hat. So first off, the hat connects to the NVIDIA Jetson Nano over the top of its GPIO header, with the hat hanging off the edge. Now the servo hat supports up to 16 separate servo channels with external power through USB-C port, as well as access to our quick ecosystem with a quick connector on the other end. I'm going to hook up our servo to channel 0, taking note of ground and signal. And then our quick OLED display is going to get connected to our quick connectors with our cable. On the back, I have 2 connectors to choose from. I'm going to use the bottom. And I'm going to connect it to the hat here. And with that, our hardware is assembled and ready to go. Let's go jump into code.
A little bit of background before we get started. First things first, I did hook up and add the webcam, the Logitech webcam that comes with, as well as I've also added the Edimax N150 Wi-Fi adapter. It's a USB adapter, and already ran a system update and system upgrade just to get everything up to date on my DLI image. I prefer to use a keyboard and monitor when working with the NVIDIA Jetson Nano and Jupyter notebooks. I know that you can access it from a laptop or any other computer that's on the same network as Jetson, but in terms of response, I found that it's best to use a keyboard, mouse, monitor. So I'm going to go to localhost, port 8888. That should bring up our Jupyter Lab notebook, similar to anything else that you've done with the DLI course if you're following along, or even the Jetbot matter. So we'll get a loading page. Now, once the Jupyter Lab notebook open, you'll have your examples, classification, hello camera, and images, directory, and regression examples. I have a couple of things added here for DLI. Those will be accessible to you through other tutorials later on. But the first thing we want to install libraries. To do that in Jupyter Lab's notebooks, we open up a terminal window. And we install it through pip. So we go sudo pip3 install SparkFun-quick. It's going to ask for our password, and again, it's DLI Nano, unless you've changed it. If this is your first time installing these, it will download and configure all of the packages. I think there's about 14 different Python packages for 14 different quick boards we have access to. As you can tell here, all my requirements are already satisfied, so I have everything installed. We're good to go. But for you, it would install, take a little bit of time, and then move on from there. So now I can use quick Python libraries in any of my DLI course notebooks, or I can create a new one. So the example that I decided to start playing with and exploring was the classification example. I'm going to open that up. Now I've already gone through and trained this example. You should have too if you've taken the DLI course, and I highly recommend that to do that. I've been playing around with the idea of creating a headless version, so it's not using Jupyter Notebooks at all. I'm not done with that yet, so I'm not going to open that and show you. But I'm going to open up the classification notebook. It looks very similar to the DLI course. In fact, it is the DLI course. And as I scroll down, we do the initial setup for the camera as normal. But notice that I've imported the quick micro OLED library OLED display, and then I started it. And then at the very end of this cell, I clear the display. I set the font size to 1, a little bit bigger font than normal, and then put the cursor in the upper left-hand corner, 0, 0, and then I print good to go, finally calling display. I like doing this right away, rather than the end, especially at a lengthy notebook like this, rather at the end so that I get a good hello world and to make sure that everything's up and running and working, and I don't have to go through 6 cells just to see if my code works. As I scroll down, we didn't change the task at all, but we might do that here in a second. Data collection, again, nothing changes here. Model, nothing, again, changes in our model. Where the magic happens is this live execution cell. We add from the PyServo hat, we import the PyServo hat. We instantiate a servo as PyServo hat, and then restart the hat, just in case if it's getting some funky signal from somewhere, we want to make sure we're restarting that and starting fresh. To start with, we also move the servo to position 90, so straight up and down. Again, this is channel 0, position 90, and our maximum angle, or the angle of our servo as it's designed and intended for. As we scroll down, the inside of the live function is all of the logic for what happens when, in terms of when it gets a thumbs up or a thumbs down. So again, it captures the camera and it processes it, and it finally makes the decision and the prediction in terms of what of the 2 category index values the camera is seeing and the Nano is figuring out. So in what I created and added right here is that if the dataset category index is thumbs up, we clear the screen and we print out win, and then the servo moves to 150 degrees. Else if it's thumbs down, in other words, if that category is thumbs down, we clear it, set the font again, and we print lose, with the servo moving to 30 degrees instead of 150. So as I start this code and run it, if I give it a thumbs up and everything is good to go, my OLED will print out win, my servo position will move to 150 degrees. If it's thumbs down, my OLED will print lose, and the servo will then move to 30 degrees, and back and forth as I change my thumb up and down. So real quickly, we're going to run this code to get it up and running, and then we'll show you the widget in function. Again, I like to go through these cells one by one, and my OLED just shows good to go. I know you don't have any visual feedback right now, but you will get some later on. And I'll move on to the task, wait for the print. Okay, my 2 tasks. Okay, my 2 tasks. Play again. Wait for the data collection. Model. Again, you can run all these cells at once to just run it all. I personally like to do this and step through things. Probably just heard the servo move, so that's at 90 degrees currently. Move on through training. And combine all the widgets into one display. So we have a live project. Adjust the camera down. So my existing model, I have to load it, and then for some reason or another, again, I'm not sure, I have to evaluate it for this to start working in a live situation. So I'm going to load my model, and I'm going to evaluate it. Okay, now we're in a live situation. You can see the prediction is saying thumbs down because there's nothing in the camera. And if I hold this up, if I hold up my thumb, I get a thumbs up, thumbs down, so our prediction engine is working. And you can hear the servo moving. And if I take the servo, and I add it, and just to help visibility's sake, I can take something like Sharpie and get this out of the way. Do this. Say, lose. Okay, and over here is win. So now I can give a thumbs up, goes to win, thumbs down to lose. It's hard to see, but the OLED display is giving lose, and it changes to win. So that's a really simple hardware demo that you can add to this. Again, the visual of this, I apologize, I'm using that. Insane. But that's just a way of adding, really quick way of adding some SparkFun hardware, an OLED display and a servo, and combining that with the existing example code of the DLI course.
That wraps up this quick demonstration of integrating SparkFun hardware into the DLI course examples. I hope it inspired you to try the same and dig into some machine learning. If you have any questions, feel free to leave them in the comments below or on the SparkFun forums.